let's take a look at this one. So the question is asking you, this one here, which equation describes the graph below, and to justify your answer. So I'm going to show you a little trick of how to justify your answer. First, what I would do here, I'm going to change my pen color to blue so you can see here. First of all, I'm going to look at where this line intersects evenly here. So I see a point here. I see another really good point here, one here, and then one down here. With those, I'm going to make some ordered pairs. So whenever you're plotting something on your graph, you have X and Y like that to plot your points. So that's what we're going to do here. So let's make a few ordered pairs. So if we look here, we see that the X value is -2 and the Y value is at 4. So that's our first ordered pair. Okay, let's take a look at the second one. The X value is -1 and the Y value is at 1. All right. Next one, we'll take a look here. The X value is at 0 and the Y value is at -2. And then the last one here, we have the X value at +1. Sorry, I'll just make that there. And the Y value is at -5. Now that we have those, we can just take these numbers and punch them into these equations. Now what you're looking for in order for you to choose the right equation is that whatever is on this side of the equal sign is equal to whatever's on this side of the equal sign. So the numbers should be the same. Now to make the video a little bit shorter, the correct answer is this one here. And let's take a look at why. So if we write out this equation, y equals -3x minus 2. Let's take just one of our ordered pairs. Okay, so I'll switch back to red now. Let's take this ordered pair here and plug the numbers in. So our y value is this 4. Remember, because x and y, it always goes x and y. So let's put 4 on this side. And then we'll take the -3 multiplied by -2 minus 2. Now, we'll bring the numbers down again. This is how you're justifying, again, showing your work like your teacher always asks. So, let's do -3 multiplied by -2. If we multiply two negatives together, they become a positive. So these cancel out, and they become positive numbers. So we have 6 minus 2. Then we have 4, and then we have 6 minus 2 equals 4. So we know that those set of coordinates are on there, this describing this linear equation. So just to keep going, let's do the rest as well and see if all of these plot points, when we put them into this equation, if the number on this side equals the number on this side, then we know that this equation is describing this line here. All right, so again, y equals -3x minus 2. We'll take the y value as 1. Then we'll take 3 multiplied by -1 minus 2. All right, so we have 1. And then remember, two negatives multiplied together gives you a positive number. So 3 times 1 gives you 3 minus 2. So then we have 3 minus 2 equals 1. So again, we have numbers that equal on both sides. So this one checks out, this one checks out. We're looking pretty good here. We do y equals -3x minus 2. Let's plug this one in. So our x is going to be -3 times 0 minus 2. And our y is also, sorry, we'll scratch that out, we'll put in minus 2 there. So we'll bring it down again, minus 2 equals, now -3 times 0. Anything times 0 is 0. And so we have -2, and we have 0 minus 2, which gives us -2. So you can see equal on both sides, which checks out. And then let's do our last one here. I'm just gonna get rid of this so we have some room. What was it again? Sorry. There we go. Let's write our equation again and plot in these coordinates. So our y is -5, and then our x is 1. Okay, so -3 times 1. Okay, so we'll bring it down again. We know that a negative multiplied by a non-negative retains the negative number there. So -3 times 1 is -3 minus 2. So -3 minus 2 is like adding a -2. So we have -5 and -5 on each side. So this one checks out as well. So just to review, that's what I would do is if you're given a graph like this and you're given this kind of question, look for these coordinates first, okay, of where the line intersects nicely on these corners of the squares or where they intersect the x and y line evenly. I would make these ordered pairs. Remember using this formula of x and y. And then once you have those numbers, then you just plug them into the equation. Again, you're looking for numbers that equal on both sides. Now, we don't have time to show this, but if you were to put these numbers into these equations, what you will find is that the numbers on this side will not equal the numbers on this side. So you know that this one, and this one are not describing this line. Only this one, because again, you have numbers that are equal on both sides. Hope that helps.